This is a hypercritical moment to pay attention. All right, so this might be, well, this is definitely going to be repetitive, but from what we did last time. But like I said, there are a few people not here, and there are always a certain percentage not paying attention. So perhaps I can clear some of that up. All right, so the unit that we just finished was Unit 1, okay? And it was called, and still is called, Digital Information, okay? We just did the assessment last time and all of that. If we were to continue as expected, we would go to Unit 2, the Internet. Now, the current year curriculum for this unit has taken out a lot of the lessons, or the way they are doing the lessons is different, and I think less engaging and less fun. So we are actually going to do the Internet unit from 1920, let's say 2019-2020 school year. But in that year, it was under Unit 1. Like I said, I've said this before, that there are probably a dozen different topics in this course, but they cram them into 5 or 6 different units. And because that, there are sort of like strange combinations, just like at the end of the unit we just finished, where the unit with binary and compression also has copyright. Technically, it's all digital information, which is why they give it a title that makes sense, but those topics don't really go together. Either way, the unit we're going to do now is Unit 1, the Internet, from this year's curriculum. How does this affect you? Well, it doesn't, in that when you go to your My Dashboard, if you go down to your class, the current unit will be, and has already switched to, the one we're about to do. So every day when you come here, you're just going to click on your My Dashboard in code and go to the current unit. The only time that you would need to worry about this is if you need to access the lessons from the unit we just finished. I don't want to say old unit because it's technically newer in years, but old in that we just did it. If you need to access lessons from the unit that we just did in order to do them late, which a lot of people missed some check for understandings, you go up here to the full year curriculum of the one that we switched to, which is at the top, and or from My Dashboard, click on the course name right above current unit, which is right here. The course name, this is current unit, this is right above that. You click on that, and you should be able to switch version to 2021. And when you do that, you should be able to go to Unit 1. I'm not entirely positive that will work every time, but if it doesn't work, come in at lunch and I'll set everything up for you so you can do it. All right, so carrying on with our new Unit 1, and that's another thing. The assignments for what we're about to do are still called Unit 1, and I know there's probably 3 people in the room at any given time not paying attention. They're going to say, they're going to have a grade on Canvas that says Unit 1, Lesson 6, 0, and they'll go back and check Unit 1, Lesson 6, and they'll have done it because it was a different Unit 1. If you're confused, come in at lunch. We'll explain it. This link right here is to a YouTube video that explains it which is what I just went over last time. How's the sound on this? Do we have sound?
The current units will be.
There we go. Sounds familiar. So there's that. I think I need to put these on a presentation. Give me a second. Hold on. Make your way to the new unit. And I need. This is just to make sure you can access this video later. Hey guys, settle down. Shh. Do stop talking. Thank you. And let's share this. And share anyone with a link, copy link, and let's change this to that. All right, so we are going to go ahead and go with the new Unit 1, Lesson 3. Okay, and if we go, you'll see on yours, it will probably say Lesson 3, Lesson 6, and Lesson 7 are open. That is where we are headed. Okay, I've actually put out a fair amount of track in front of us, and we're probably going to stick with it. You know, that's another 2 weeks of curriculum or lessons. You will notice that some of the documents linked here in the calendar say printout, and they are also PDF files, which is redundant. They are also PDFs. That means you're going to get a worksheet. I don't want you to do it digitally. There is a reason. It is. I would prefer to do things all digitally, but if there's a benefit to doing it analog on paper, that's why we're doing it. The only reason I'm linking them here, even though I'm going to provide you a copy, is if you're absent, you can print out your own. Obviously, you can come in and get it. I'll print you a copy here if you want, but if you just want to go ahead and print one out and do it, there's that. And yeah, so over here, it will say what's actually due. Okay, so for lesson 6, which we're not doing today, but there is an activity, meaning like a digital workshop to be handed into Canvas, which is why it says -CPS, and a printout, and the explanation of the due date, or in the due date, it says both lesson 6 documents and lesson 6 check for understanding. So let's go ahead and get going with lesson 3 from current unit. And it says lesson 3, sending binary messages with the internet simulator. Go to current unit and get this up on your screen. Just go to, make sure you can get to code because you're about to interact with it. Also, the activity for this, the internet simulator, requires you to work with at least one other person. You can do it in a trio. If we end up with an odd number on one side of the room, but the trio, there'll still just be 2 computers connected, and the 3 of you will be looking at both computers. This isn't a test to see if you can communicate across the room without talking. The 2 of you in your duo, ideally a pair, are both looking at both screens and are going to test your ideas, explaining in a second. But the point is, you need to figure out either a partner or a trio now. No 4s. A 4 is just 2 2s. Don't need to join yet. Don't join a server. Don't click on anything yet. You need to explain a lot of things. Okay, so lesson 3, sending binary messages with the internet simulator. The internet simulator is a aspect of most of the lessons that we are going to do. And they actually, this is the feature that they've cut down on in the current year's curriculum, which is why we're doing this. I think the internet simulator has a lot of benefit. But regardless, we're going to go ahead and do lesson 3 today. Lesson 3, there is this internet simulator activity, which is the one side of your yellow worksheet. And the other side is a video worksheet. And we will do that also today. It shouldn't take too terribly long. Okay, so some vocabulary. This is another thing they changed, just an aside. The bubble 1 used to always be vocab and links. They've sort of eliminated that. They've put it in student resources, like another sort of thing from the current unit, but that's an aside. Okay, so topics for today. Bandwidth is transmission capacity. How much can be sent at the same time? Bit, we already know. A bit is either a 1 or a 0. It's the smallest piece of information that there is in a binary, well, it's the smallest piece of information that there is. It's a 1 or a 0 in a binary number system. It's on or off if it's some electrical current and all of that. Bit rate is how fast a transmission can be sent, or the amount of bits per second, and that is the bandwidth. So it's essentially the same thing. Latency is the same thing as lag. It is the time it takes to send the information from one place to another, which is different than how much can be sent at once, but it's related. And the key is protocol. You are going to be making several protocols based on the lesson. Essentially, it's one per lesson, forcing you to think about a problem that the internet has solved as a way of understanding how the internet works. A protocol is a set of rules governing the exchange of transmission of data between devices. Protocol has a meaning outside of computer science. This is protocol, and actually protocol in general is just a set of rules for doing something. For the protocol for administration, if somebody gets in trouble, is call parents, assess, damages, or have student conference. Like, it's the step-by-step rules for doing something. With regards to computer science, or specifically networks, it's the agreed upon process of transmitting things. The protocol for Morse code is not just the guys. You guys go and turn off screens, keyboards down, laptops down. I'm feeling a lot of not productivity going on, or not paying attention. Go ahead and turn off. Yeah, that one doesn't. Okay, so the protocol for Morse code is obviously, it includes the dots and dashes chart, but it includes things like who's deciding who's the sender and the receiver. Okay? Morse code is a symmetrical, or should say telegraphs, are a symmetrical situation where the sender and receiver have the same equipment, and they can't talk to each other than with the telegraph itself. And we can all picture somebody going dot 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 dash dash dot 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 dot, and sending a message that you convert into text. But how do they know when they're the receiver and when they're the sender and when to switch? There's a protocol involved. And it's the same thing in networks and computer science and computer communication. And that's what we are going to learn about. The internet simulator, which is Bubble 2, don't go to it yet, is, like I said, going to be on several of the lessons that we work on with different aspects allowed and different problems abstracted. Okay, abstracted meaning simplified or removed from the situation so you don't have to worry about it. Let me see if I can get my sound. That's probably good enough. All right, so watching the video, quiet.
Welcome to the Internet Simulator tool for computer science principles. We will be using the Internet Simulator to study issues about how the Internet works and also how data is represented and transmitted. I'm a software engineer here who helped build this tool. The first problem you have to solve with the Internet Simulator is to encode a small piece of information in a binary state and communicate to a friend using a shared wire. Let's show you how to connect. When you first open the simulator, if you are logged in, you will see the lobby, which shows you everyone else in your class who is also logged in and looking at the simulator. Identify your partner in the class list and click Join. When you do, you will see an outgoing connection request below the lobby. A request has been sent to Alex asking to connect. Meanwhile, your friend will see an incoming connection request, which she can accept. Either partner can make the request to join together, but one will make the request and the other will accept it. Once connected, you will see yourself and your partner represented as two nodes connected by a wire. Either one of you can set the state of the wire to either state A or state B. You can do that by typing an A or a B in the send box and clicking the set wire button. That will set the state of the wire to A for the moment. We'll explain why the graphic turns to a question mark immediately after you set the state in a minute. You can also type out the string of A's and B's that you want to send ahead of time, and then click the set wire button repeatedly. It will take the A or the B at the front of the line and set the wire to it. You or your friend can read the wire at any point. Clicking Read Wire simply records the state of the wire at that moment in time. There is no guarantee that it will have changed state between clicks. Of course, if you set the state of the wire, you can also read it yourself. The most important thing to know about this simulation is that the wire between you and your partner can only be set to two states, A or B. And you can't know the state of the wire until you choose to read it. You will have to coordinate to decide whose turn it is to use the wire. This is the reason that you see a question mark once you have set the state of the wire. Since both you and your friend can set the state of the wire at any point, once you set it, there's a possibility that your friend might also set it at the same time, and before either of you reads the wire. Send the message to a friend using a shared wire requires coordinating and careful tuning. To help with that is a timer that you can use to help you maintain a regular pace. Click on the My Device tab and see the timer. Adjust the slider to have it pulse at different rates. The timer isn't connected to anything. It's just a metronome, there to help you and your partner coordinate. With a well-thought-out communication protocol and the pulse timer, you and your partner will be able to send and receive messages accurately and efficiently. Good luck.
All right, so go ahead and find your partner and join the section and join and connect. Okay, figure it out. Sit next to somebody who doesn't have a partner yet. Raise your hand. Who doesn't have a partner yet? You can hop over there.
Actually, no, I'm gonna work with this.
Anybody else still have a partner? You have a partner? Okay, you can hop over there. Anybody else still have a partner? This isn't going away. All right, who can work for the? All right, if you are a trio, listen up. If you are a trio, only 2 of you are going to connect. Please stop talking for a second. Do stop talking for a second. Do stop talking for a second. Thank you. If you are a trio, only 2 of you are going to connect, but that's fine. All 3 of you will be looking at both computers. If you're in a duo, both of you will be looking at both computers until you get to the end and can test your protocol. Now, the situation, a lot of the criteria is contained for you. Guys, go ahead. Let's join and then wait. I want to see everyone's screen with 2 bubbles next to each other. You guys probably need to be sitting next to each other. There you go. I see problem solving. Just let's get both. I want to see every screen that's up with both nodes. That's what the 2 circles are. And then wait. All right, so the idea is that you and your partner are going to come up with a set of rules that will allow you to send a 2-bit message, 2-bit meaning 2 binary pieces of information. In this case, the binary is A or B. So there are 4 possible 2-bit messages, AA, AB, BA, and BB, okay, which has a problem or a challenge inside of it or with that because, well, the way it's set up, okay? So one partner is going to have a secret message. I mean, the key is that you're setting this up so that it works with any one of those 2-bit messages. And when I say go, okay, well, this is just, the idea is that you would be able to send the message. And the second partner will send the message back to confirm. Okay, this idea of sending and confirming is something that you'll see several times. But again, the key is the set of rules, your protocol to make this happen. Okay, some of the challenges to make this happen are, how will you know when it's supposed to begin? Which is the same way of saying, how will you know when the receiver needs, well, we'll say person 1, person 2, because once the message goes from person 1 to person 2 needs to send it the same thing back to person 1. So I won't say sender and receiver. Person 1 needs to send the message to person 2, and person 2 needs to send it back. You need to decide on, the key is when the receiver of whichever direction it's going clicks read wire. So if you click on my device, you'll see there is a pulse rate, and that is critical because, let's say, as the sender, I send, and you can't see both of my screens, but let's say the message is A, B. I set the wire to A and pretend I'm the receiver over here. I read wire, I get the message of A. Then before the sender sets the wire to B, the receiver hits read wire again. If they click read wire before the message has, or before the sender has changed the wire to the other situation, they'll get the wrong message. But maybe the message is AA, and that's why they won't know it's the wrong message. So you need to agree upon when something's going to happen. Okay. Another critical thing is agreeing on a and I probably should have let you guys struggle with that and decide, have an aha moment about agreeing on a pulse rate. Some of you may have, that's just sort of intuitive that if the pulse rates aren't going at the same speed, then it's not going to work. But also this is why you need to look at both people's screens, because I'm not sure the pulse rates always start at the same time, especially if you're moving them back and forth. You can kind of get them to line up exactly, but a slower pulse rate will make things easier. So you need to decide how or when the exchange is supposed to begin, how you will know whose turn it is to receive the message, and how will you coordinate the actions. All right, so right now you're playing around with setting the wire and reading the wire. You don't need to work into your protocol. Like if you imagine in Morse code, you do da 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 stop, da, da, like end of message. We know at this point it's a 2-bit message. The key is, how are you going to solve the problem of who does what when? Okay, that's the question to answer. Who does what when? Okay, so playing around with setting the wire and reading the wire. Try to figure this out. How can you do this? All right, go. Yes. We are on the side called Activity Guide, Coordinating Binary Messages. We're going to do the video worksheet later today. And everyone is doing this. Everyone is handing their own. Worksheet is due at the end of class. And here we go.
My name is Tess Swinlock. I'm a software engineer at Google. Here's a question. How does a picture, text message, or email get sent from one place to another? It isn't magic. It's the internet, a tangible physical system that was made to move information. The internet is a lot like the postal service.
I don't know why this is so poor quality.
From one place to another.
All right.
It isn't magic. It's the internet, a tangible physical system that was made to move information. The internet is a lot like the postal service, but the physical stuff that gets sent is a little bit different. Instead of like boxes and envelopes, the internet ships binary information. Information is made of bits. A bit can be described as any pair of opposites, on or off, yes or no. We typically use a 1 meaning on or a 0 meaning off. Because a bit has 2 possible states, we call it binary code. 8 bits strung together makes 1 byte. 1,000 bytes all together is a kilobyte. 1,000 kilobytes is a megabyte. A song is typically encoded using about 3 to 4 megabytes. It doesn't matter if it's a picture, a video, or a song, everything on the internet is represented and sent around as bits. These are the atoms of information, but it's not like we're physically sending ones and zeros from one place to another, one person to another. So what is the physical stuff that actually gets sent over the wires and the airwaves? Well, let's look at a small example here of how humans can physically communicate to send a single bit of information from one place to another. So say that we could turn on a light for a 1 or off for a 0, or use beeps or similar sort of things of like Morse code. These methods work, but they're really slow, error-prone, and totally dependent upon humans. What we really need is a machine. So throughout history, we've built many systems that can actually send this binary information through different types of physical mediums. Today, we physically send bits by electricity, light, and radio waves. To send a bit via electricity, imagine that you have 2 light bulbs connected by a copper wire. If one device operator turns on the electricity, then the light bulb lights up. No electricity, no light. If the operators on both ends agree that light on means 1 and light off means 0, then we have a system for sending bits of information from one person to another using electricity. But we have a problem. Let's say that, we want to send 5 zeros in a row. Well, how can you do that in such a way that either person can actually count the number of zeros? Well, the solution is to introduce a clock or a timer. The operators can agree that the sender will send 1 bit per second, and the receiver will sit down and record every single second and see what's on the line. To send 5 zeros in a row, you just turn off the light. Wait 5 seconds. The person on the other end of the line will write down all 5 seconds, say 0, 0, 0, and for ones, do the opposite, turn on the light. Obviously, we'd like to send things a little bit faster than 1 bit per second, so we need to increase our bandwidth, the maximum transmission capacity of a device. Bandwidth is measured by bit rate, which is the number of bits that we can actually send over a given period of time, usually measured in.
There's 2 of the answers. You can look it up later if you need to, but there you go. You can just do it now.
Seconds. A different measure of speed is the latency, or the amount of time it takes for 1 bit to travel from one place to another, from the source to the requesting device. In our human analogy, 1 bit per second was pretty fast, but kind of hard for a human to keep up with. So let's say that you want to actually download a 3 megabyte song in like 3 seconds. At 8 million bits per megabyte, that means a bit rate of about 8 million bits per second. Obviously, humans can't send or receive 8 million bits per second, but a machine can do that just fine. But now there's also a question of what sort of cable to send these messages over and how far the signals can go. With an Ethernet wire, the kind that you find in your home or office or school, you see really measurable signal loss over just a few hundred feet. So if we really want this internet thing to work over the entire world, we need a different way of sending this information really long distances. I mean, like across an ocean. So what else can we use? Well, what do we know that moves a lot faster than just like electricity through a wire? Well, light. We can actually send bits as light beams from one place to another using a fiber optic cable. A fiber optic cable is a thread of glass engineered to reflect light. When you send a beam of light down the cable, light bounces up and down the length of the cable until it is received on the other end. Depending on the bounce angle, we can actually send multiple bits simultaneously, all of them traveling at the speed of light. So fiber is really, really fast. But more importantly, the signal doesn't really degrade over long distances. This is how you can go hundreds of miles without signal loss. This is why we use fiber optic cables across the ocean floors to connect one continent to another. In 2008, there was a cable that was actually cut near Alexandria, Egypt, which really interrupted the internet for most of the Middle East and India. So we take this internet thing for granted, but it's really a pretty fragile physical system. And fiber is awesome, but it's also really expensive and hard to work with. For most purposes, you're gonna find copper cable. But how do we move things without wires? How do we send things wirelessly? Wireless bit sending machines typically use a radio signal to send bits from one place to another. The machines have to actually translate the ones and zeros into radio waves of different frequencies. The receiving machines reverse the process and convert it back into binary on your computer. So wireless has made our internet mobile, but a radio signal doesn't travel all that far before it completely gets garbled. This is why you can't really pick up a Los Angeles radio station in Chicago. As great as wireless is, today it still relies on the wired internet. If you're in a coffee shop using Wi-Fi, then the bits get sent through this wireless router and then are transferred to the physical wire to travel the really long distances of the internet. The physical method for sending bits may change in the future, whether it's lasers sent between satellites or radio waves from balloons or drones, but the underlying binary representation of information and the protocols for sending that information and receiving that information have pretty much stayed the same. Everything on the internet, whether it's words, emails, images, cat videos, puppy videos, all come down to these ones and zeros being delivered by electronic pulses, light beams, radio waves, and lots and lots of love.
All right, so key is different ways. The physical internet is made up of different components that are connected so that you are connected. The answers to most of the worksheet are on the first bubble of the lesson. These are the definitions for our vocab. And you can watch the video again, if you like, on bubble 3. Okay, and I will take this worksheet when you are done. Make sure your name, date, and period is at the top of both sides. You can put it in the tray where you got it. You also need to do the check for understanding from this lesson. And you have plenty of time to complete it today. I think we're done at 43.
What's up? Yes. Rate a pass, just for funsies.